Hi everyone, and welcome back to this channel. Today we're going to be considering a special application. The name of the application is Survey Map or Geospatial Survey Map. This is the application, and I'm going to be walking you through how to use the first tool in the application. This is the application. Geospatial Survey Map was developed by Surveyor Damilola Kolawole, the CEO of Geospatial Information Resource Limited. He's a software developer and a GIS expert. I will walk you through some of the functions that you can find on this software. Number one is back computation. If you have your coordinates and you want to prepare your back computation and also prepare the map, you can use back computation. We have coordinate adjustment. We have bearing and distance. And this bearing and distance is computing your survey from bearing and distances. That is, you have your starting coordinates and you carry out observation using total station, whereas you have your bearing and distance, or you have computed from angle and distance and you have your bearing and distance. You can compute your survey and produce the plan using bearing and distance. You can also do that with angle and distance if you have just angle and distance. Survey map also has layout manager, whereas you can use direct layout using back computation. It has alignment also, ray computation, that's leveling, that's spot height. Coordinate conversion is one of the powerful uses of geospatial survey map, and it has mapping. You can actually store your coordinate here as it has coordinate register and records. So today I'm going to be focusing on back computation, and in subsequent videos I'm going to be exploring other usefulness of this, starting from bearing and distance, angle and distance, and so others. So with back computation, I'm going to click on back computation now, and this is the back computation page. We're going to be importing coordinates from either Excel, CSV, or text file. For the sake of this tutorial, I'm going to be using text file. So I'm going to navigate to where my coordinate is, and I'm going to show you the coordinate and how to format the coordinates so that it's going to be compatible with Geospatial Survey Map. And this is the coordinate. You can see I have pillar 1, a set of coordinates, comma, then another coordinate. This pillar 1 is the pillar ID or the point ID. Then the first coordinate is the northern coordinate, and this other one is the eastern coordinate. You can see that they are separated by comma, and that's how you format it. You can see that pillar 1 was also repeated as the last pillar here. That's to have a closed loop. If you have an open loop, you can leave it as open loop. But this one is a closed loop, that is a rectangular figure. So that's why we have pillar 1 starting and pillar 1 ending. So I'm going to close it, and I'm going to go back to Geospatial Survey Map here, and I'm going to import my coordinates from text file. Then I'm going to navigate to where it is. This is it, and I'm going to open it. This, you can see station, northings, and eastings. It is good to know that you cannot interchange eastings here and northings here. It must be station, northings, and eastings, and it's a must you put your station ID there also. So the next thing to do is to click on compute back computation. So in a couple of seconds, you can see it has computed my back computation, and I'm going to click on report here, and I'm going to maximize it here. You can see well detailed and neat report here. This is the back computation from the coordinate we just entered. You can see the change in eastings and the change in northings. You can also see the distance and the bearing. Also, the area in square meters is also listed here, and the area in acres is also here. So this is the back computation in Geospatial Survey Map. So you can convert this map, this computation, to map, that is to survey plan. So I'm going to click on convert to map. You can see this is how my coordinate look like. This is the drawing of the coordinate. So I'm going to zoom out. Yes, this is how it looks like. So I can export it to AutoCAD also. That is, I want to continue the work on AutoCAD. So I'm going to do that is I'm going to click on export to AutoCAD here, and I'm going to save it as Babatunde. And I'm going to save it. You can see that it is script file, that is SCR file. So I'm going to save it. Then I'm going to come to my AutoCAD. I'm going to set the initial units. I like working with 3 decimal places. Okay. And I'm going to come to manage, and I'm going to run it as scripts. So I'm going to come here and go to where I've saved my work. So I've saved it in Dropbox inside this particular folder, and this is Babatunde. I'm going to open it here, and this is the work. You can see the beauty. It has already been labeled, the pillar numbers, and the bearing and distance also properly labeled. All you have to do is just adjust it and put it in the correct, in the proper position. It's in the correct position, but proper positioning. So, and this is how to use Geospatial Survey Map, the back computation part of it. You can also export your report either as an Excel document, a PDF, or Word document. So I'm going to export this as a PDF document now. You can see it's exporting. So I'm going to save it as this report back computation. I'm going to leave it like this and save it. Then we are going to be previewing it from, this is it. So let's open it. Yes, we can see that this is well presented and it is presentable for all type of applications. Thank you. And this is how to use Geospatial Survey Map, the back computation part of it. In the next video, we are going to be considering the bearing and distance part of it, and subsequent videos we are going to be covering other parts of Geospatial Survey Map. Thank you, and God bless.
Free audio post-production by alphonic.com.